So how do you write the results section? So you've done all that hard work, you've introduced the reader in your introduction to the kind of the background and the rationale and your hypotheses and your aims, and you've hopefully taken them through a method which has got a series of kind of structures in terms of procedures and the materials and the statistical and data analysis. Now comes the part where in essence you're going to showcase what you have found. And as with all of the sections in your report, make sure that it lacks ambiguity. So one of the things that is really important in a results section is that it is clear and it is concise. So you don't want to have a results section that is waffling and is full of information that is not needed. Remember that the fundamental thing that drives everything that you report is the research aim and those hypotheses. Remember, the hypotheses have to be testable. If you need to remind yourself about hypotheses, go and watch the supporting video on hypotheses and then perhaps come back to this section. So when we're thinking about the results, it's about having an effective results section. And a lot of this is driven, as I say, by the kind of analysis that you have done. But the key is very much you want the information to be clear, concise, and objective. Now, what we mean by objective is here that do not confuse a results section with making any commentary on the results which you have found. It is purely about, it's very, very objective. This is what was found. It is not this is what was found and this is maybe what it shows. It's not that. That is where in essence we move into the discussion. Make sure that when you are constructing your results section that you make use of a number of different approaches. You may use text, you may use visual aids, so it might be tables and figures. If you want to understand a bit more about how to correctly structure tables and correctly structure figures, go and watch the separate videos on how to do those. We need to also show our statistical outcomes. Remember, there's a difference between statistical analysis and data analysis. So data analysis has been done. We're now into our statistical analysis. So you've now got to report these. And as with all other sections in your report, you're going to lead the reader through the findings because you're trying to drive them towards the implications of the study. So remember that the results should be reported in the order which the hypotheses were stated. Okay, so keep that in mind, that the order in which you state your hypotheses is the order in which your results should be presented. You do not want to be interpreting the information. It is purely an objective kind of chapter. So you provide them with all the analysis that's been undertaken in order for them to start making conclusions. So in other words, it should be possible for the reader to almost be ahead of you as the writer. A good results section should leave the reader at the end of it almost like reading a detective novel, going, I think I know what they're going to conclude here. If the reader gets to the end of it and feels kind of washed out by what they've read or doesn't really seem to know what's going on, then it's either not being concise or it's not being very clear. So again, bear those in mind as you're constructing the results section. They should be able to get to the end, as I say, and kind of have an idea which way you're going to go with accepting and rejecting those hypotheses. And they can start to make a suggestion in their own minds about what we call clinical importance. That is really the notion of, does this actually mean anything? Does this actually have relevance? Make sure that it's always written in the past tense, because again, as with all other sections in the report, it is not what we're going to do, it's what we have done. And just, again, make sure that it's very logical in the way in which it is structured. So let's have a look at an example of a results section and just see how this kind of conforms to what we have set out here as our basic rules of engagement. So here we have the results section. Again, this is of that same study that we've been using, which is in relation to grip strength. Now, fundamentally, there are a number of key things that we've got to report. We've got to report information which is kind of demographics. So that is information about our participants. We've got to report information which is about the statistical significance or using, for example, if we're using what's called Bayesian statistics as well, that might be things like if we're going to report effect sizes and so on, they need to be reported. And we need to do it in a manner that allows the reader to be following almost the hypotheses. In other words, they're kind of following the roadmap that you've set for them. So let's read along. So the first thing this goes with is Table 1 presents the data for all participants across the two protocols. So to remind ourselves, they've done two different protocols. So if we just quickly scan to Table 1, and again, to learn about how to get tables nicely constructed, go and watch this separate video. But here we can see we've got our trials, and what's happened in here is that they've got two conditions, which is the conditions which are FE and RP, 3 trials. And the information is giving us the scores. It looks like for the whole group, it tells us it's the whole group. And we've got the mean values, we've got the standard deviation, we've got the variance, the minimum and the maximum values have all been reported. Then it goes into the statistics. Now, do you remember, if you can't remember, go and watch the video which is on reporting and picking statistical tests. But fundamentally, getting the right test was about making sure that your data is normally distributed and is homogeneous. So actually what's happened here is that the measures for homogeneity and distribution are set out first, because that in essence leads the reader into the correct results. For all trials, the data was normally distributed. P is greater than 0.05, while sphericity was not violated. So no correction was applied. So what they're basically stating is that there was no need to make any adjustments to the statistical tests for either homogeneity or normal distribution. Non-significant differences, F equals 2.08, P equals 0.06, and then this, what's called NP squared. So NP squared is just an abbreviation for what is called partial eta squared, and it's a way of showing an effect size from an ANOVA, were observed across the RP and the FE protocols for all participants. But if you remember, one of the hypotheses in this paper was to do with sex, males and females. Separated for sex, non-significant differences were observed both within and between conditions. So think a little bit about the writing that's going on here. So within, let's just make this clear. So within would be, for example, comparing FE trial 1 to FE trial 2 to FE trial 3. And between would be comparing FE trial 1 to RP trial 1, or FE trial 2 to RP trial 2, or FE trial 3 to RP trial 3. So non-significant differences. F equals 2.08, P equals 0.06, partial eta squared equals 0.4 were observed across RP and FE protocols for all participants. Separated for sex, non-significant differences were observed both within and between conditions. So now, notice the way the results have been switched. So rather than just becoming almost rewriting it in the same way, it's just been switched slightly. RP, 36.5 plus or minus 0.08 kilograms, and FE 33.4 plus or minus 0.27 kilograms for females, but a significant difference. F equals 2.61, P equals 0.02, so it's less than 0.05, 37.3 plus or minus 0.83 kilograms, 34.0 plus or minus 0.3 kilograms for FE and RP respectively were observed in the males within condition differences FE trial 1 and FE trial 2. And between FE and RP trial 1, P equals 0.000, FE and RP trial 2, P equals 0.004, and FE and RP trial 3, P equals 0.000. Now, there's a lot going on, but the thing you've got to remember, and I think this is where we get very confused with result sections, it's not like reading a novel. This is a slightly different language, but this is the language of science. It's a language of a lack of ambiguity. So there is no chance for misinterpretation. That's the fundamental thing. That's why there is no commentary in here. So it is quite simply reporting the statistical outcome. So in case of an ANOVA, the statistical outcome is the F value. If it's a t-test, it's the t value. If it's a correlation, it's the R value. it is reporting the actual associated p-value, the probability of the level of significance, so the p equals 0.06. Remember that all of this is being reported at an alpha level of 0.05, and we'll just remind you of that. If we move up into the methods, you can see alpha level was set at 0.05, so there's a 95% chance of certainty, a 5% chance of error. Notice that for all trials where they can, because they're comparing males and females, they're giving you the demographic scores. They're telling you or reporting to you what those values are. So it's not just a case of this is what the statistics showed us, they're actually showing you the data as well. And that's fundamentally important, to show that kind of demographic data. And then they actually also report the partial eta squared where necessary. Tables, so we've already observed the table. Now we've got an image. So here we've got the figure, and the figure is comparing grip strength scores across males and females. And again, if you want to know about how you pick the right graphs and so on, go and watch the video on that. And then we get into what are the limits of agreements graphs. And again, if you want to know about limits of agreements and how to construct these, go and watch the video on those. But they are also reported. The bias, plus or minus 95% confidence intervals for the FE condition were 1.6 plus or minus 6.4, and then it gives you the confidence intervals. And so what it's doing is, it's led the reader through, so it's given us the very broad statistics, and then it's taken us into this specific analysis. Now, just remember what was mentioned earlier on, that everything follows kind of a pattern. Remember that I said it's about addressing your results in the order of the hypotheses, but it's also about addressing your results in the order in which they are kind of reflected in the methods section in terms of the statistical analysis. Look. So remember that in this section here, we've moved from our inferential statistics, which is our ANOVAs, and then we've moved into, from the group, into the sexes, and then we've actually looked at the reliability using our limits of agreement. So if you look at the methods section, just to remind you, data are expressed as means plus standard deviations. Table 1 presents the data for all the participants across the protocols. They were assessed for normality using Shapiro-Wilk, and homogeneity was verified using Levine's test. For all trials, the data was normally distributed while severity was not violated, so no correction was applied. Minimum number of trials were determined using a one-way repeated ANOVAs with post-hoc analysis applied through a Bonferroni correction. Non-significant differences, F equals, and off we go. We're into the ANOVA section. Reliability is assessed using limits of agreement and Bland-Altman plots. So this is all ANOVA, and then we come into the Bland-Altman plots and the limits of agreement that you see here, and then we get the kind of final part on limits of agreement. So hopefully you can start to see the way in which a results section is constructed. Now there are additional videos on understanding the way in which you present information in a results section, the way in which you present graphs and tables and so on, but hopefully this one is at least giving you an idea of the wording that you need to do and what are kind of the minimum requirements in a results section for a report.